everybody, I'm Heli and I work with Maggie and Rachel on a household tasks app. I worked on both front-end development and a back-end development and also with the user interface design. The idea for our app came from a problem, how to get the household tasks done and how to get everybody to contribute their fair share to those tasks. We decided to add game features to our app to make it more interesting. So when the user will complete the task, they will get points and rewards, and also the whole household competes as a team. We wanted our app to be really easy to use, with a very clear user interface. To get started with the brainstorming, we decided to do a quick wireframe in Adobe Illustrator. It's visible here on the left-hand side. This gave us a really good starting point to visualize how the app would actually look. Then on the right-hand side, you see a more complete design. So first screen, there's a login page. Second screen, there's a create a house screen. And then the third one is a dashboard where all the tasks are visible, where the user have got their own tasks. And you can also see the clear leaderboard component on that. This gave us a really good starting point for the front-end development as well, because some of these components then became a React components on the final app. We used agile programming methods for this development. First, we created a Trello board where we put all our initial ideas, then we started to filter them down to must-have features and then some nice-to-haves if you have time in end. We used the Trello board as a general source of information. We added some images, inspiration, the logos, fonts, and so on. And also used that as a to-do list. So we could select the tasks, add some tasks, and mark them done while we went along. We had several stand-ups every week, and we used Slack as a communication channel. We also did quite a lot of mob programming, and this was really useful if we had some bugs, if we needed to discuss about new features, if we were working with some more complicated components in the development. For the mob programming, we generally used Google Meets or VS Code LiveServe, where we could just jump on the same file and type and find bugs or generally work with the code together. We created 2 repos to GitHub, one for front end and one for back end. For each larger feature, we created a new branch and we worked from that branch. We communicated regularly, we committed often with the meaningful messages, and working systematically this way, we avoided any major merge conflicts. And the ones what we had, they were very easy to fix. Most importantly, we created a supportive working environment where we could all play our strengths. We help each other out, even just vent if we got stressed. And as a team, we definitely achieved more than we would have as individuals.
Hi, I'm Rachel and I'm going to be talking about front-end and back-end technologies. For the front end, we use React, CSS, HTML, Firebase, React Testing Library and Jest, and various NPM packages such as Unique Names Generator and Confetti. To build our application, we split the app down into 4 main components: a navbar, a login page, an add house component, and a dashboard component. We used conditional rendering to render the login page, add house, and dashboard components based on the state. For example, if a user isn't logged in, then the login page will display. If a user is logged in, but they haven't been assigned a house or joined a house, the add house component will render. And if a user is logged in and they do have a house that they've joined, the dashboard component will render. For authentication, we used Firebase. We allowed users to sign in using email and password. It was relatively easy to implement into our app, and it gives us options in the future to sign in with Google, Twitter, GitHub, and Facebook. We made use of a number of React hooks while building the app. useState was used frequently, and it was used to store data such as user ID, house ID, invite code, and also things like house tasks and user tasks. and user scores that were sent down to various components. We also used the use effect hook. We had set the dependency array to a counter, and this was added to every time a change was made to the database, meaning that all the house tasks, user tasks, and house scores were re-rendered every time a change was made in the database, allowing the most up-to-date data to be displayed in our app. We kept our requests to the database in a separate folder and used Axios to make these requests. This is the set user details on login request that uses the email given to us by Firebase. It makes a GET request to the user's root, and it grabs all the user's data from the response and sets this as the house ID and user ID state. It then makes another GET request using that house ID, this time to the houses root, and gets the invite code from the houses table and sets this in state. This allows it to be displayed in the nav bar so the user can use it to invite their friends to the app. We also used React testing library and Jest to write tests for our components to ensure that they are correctly rendered on screen. Moving on to Backend Technologies, we used Node and Express to build our server. We used a MySQL database, which tables included users, houses, tasks, and scores. We used SQL to query that database. We used Mocha and Chai along with Supertest for test-driven development. We used Docker to spin up an instance of a MySQL database locally, and we used Postman to help us query our routes. As mentioned before, we used Express to build our server. We created 4 main routes which coincide with our MySQL database tables. So those are users, tasks, houses, and scoreboards. And we created controller functions for each of these routes to perform CRUD operations on our database. We used request.params and request.query to get information from our database. This is an example of the getByQuery controller function that we built so that we could query the database using a query string and passing in whatever parameter we needed to use at the time. We used test-driven development throughout the process. We wrote tests for each of our routes and each of our controller functions.
Hi there, I'm Maggie, and together with Rachel and Heli, we built the House app to help households manage the never-ending chore list. I'll be showcasing our app. Once the page loads, a user can either log in if they have an existing account or register with an email and password. As Rachel mentioned, our login is managed by Firebase. I'm now going to show you the register a user route. Once the user clicks on register, we conditionally render the create a house page. Here is where a user can either create a new house or join an existing house using an invitation code. Let's create a new house together. Once they create a code, they will be issued with a unique code. This is generated with our unique code generator. This is the code that they can use to share with their house members so that they can use the invitation code to find and join an existing house. We then move to the tasks screen. Over here is where their invite code is always displayed, so they have access to the invite code whenever they are logged in. And here is the All Tasks tab. This is where any member of the household can add a task. They can either select tasks from the predetermined list, or they can add their own. Let me show you. So they can say fill the dishwasher, Uber the living room, and let's add a unique task. So add empty the bins. Any user can add tasks to the screen. Once you see a task that you would like to complete, you can click on Take It. This will then remove the task from the All Tasks screen and render it on the My Tasks tab. A user can take as many tasks as they want to. This is also where we decided to gamify our app slightly and add an element of competition. Once a user clicks on Done, they will be greeted with a little spray of confetti, and they will receive 3 points for each task that they complete. The task is removed from the My Tasks tab and the user score is rendered on the leaderboard, where house members can compete against one another. We also made our app responsive. Let me show you what it looks like on a mobile screen. As you can see, the tabs have resized to fit the screen. This is what it would look like on an iPhone XR, and our app is also responsive in other devices. I'd like now to talk through the problems and challenges we faced while building the app. Our biggest enemy was, of course, time. We wanted to build a full stack application with several routes and components, and for the most part we succeeded, but would have liked to add more functionality to the app. We also struggled building the front end and back end at the same time without yet knowing what routes we will need in our app. Getting our React components to handle data from various endpoints was also a little bit of a head scratcher, but we succeeded. We had to drop the functionality of an existing member adding a teammate from their account due to time constraints. We would like users to be able to send an invite code in an email to their household. Initially, when we first started talking about our app and what we would like to add, we wanted to add more gamification. We had the idea of My Streak, where users would get extra points if they complete the task in consecutive days. We wanted our users to earn badges or titles when reaching set targets. Currently, our household members also get 3 points for a completed task, but we would like to make the point system more complex.